Okay, here we're asked to figure out how much work needs to be done as the current loop is rotated from sort of being lined up with the x-axis to being rotated out here as shown at 60 degrees sort of from the x-axis. The easiest way to do that is remembering that there is a potential energy associated with a current loop in a magnetic field, and it's just given by the magnetic moment of the loop dotted into the magnetic field. And the magnetic moment for a loop is just equal to the current in the loop times the area of the loop. And of course the magnetic field is just the magnetic field. So to get the work done, we're going to need to do the change in potential energy. And I'm being a little sloppy with my signs here because they've only asked about the magnitude. But I can do this, so this is going to be equal to, here we have IA B, and the dot product is the cosine of the angle between them. The final minus the current area magnetic field times the cosine of the angle between the area vector and the magnetic field, the initial location. So this is going to be the magnitude of our work. And I'll just factor that out. So the current, the area, and the magnetic field show up in both cases. So it's just the difference between the cosine of the final orientation minus the cosine of the initial orientation. And here we'll have to be a little bit careful. It'd be nice to just kind of plug in 0 and 90 degrees. But if we look at the loop, the direction associated with this loop, the way to do it is to put your fingers kind of curling around the way the loop is going, and then your thumb points out. So if you think about the situation when when theta is 0 degrees, the loop is sort of along the x-axis there, but the area vector would point out. It would point in the minus y direction. So that initial orientation is actually going to be, when we have theta at 0, is actually going to be the cosine of 90 degrees, the area vector, the angle between the area vector and the magnetic field. And in the final position right here, the angle between them is not 60 degrees, but it's actually 30 degrees. And I'm sorry, you're just going to have to work through that to see how it works out. But we can put in our 50 times 10 to the minus third here. Our area, be careful, 0.03 times 0.05. And I ran out of space, so I'll put I on this side here. Wait, I already did I. I'll put B on this side here, which was 1.4 Tesla. And now it all works out and gives us 9.09 times 10 to the minus 5.